Today's video follows directly after our video on simple random sampling and covers what we call systematic sampling, or sometimes referred to as systematic random sampling. The difference between the two titles is really semantics, and the process is exactly the same whether you're doing systematic sampling or systematic random sampling. Remember that systematic sampling is a type of probability sampling, where we use the mathematical meaning of chance to select from our population a sample that will accurately represent the population. This assures that each case in our sample has a known and equal chance of being selected. This creates an unbiased sample. But how does systematic random sampling actually accomplish this? How does it pull it off? Well, as it turns out, systematic random sampling is very much a process conducted through a series of steps. Perhaps this is not surprising given its title, systematic sampling. Step 1 of this process involves acquiring a list of everybody in our population. Just like in simple random sampling, in systematic sampling, the quality of the list matters a lot. Essentially, we want a list that has no omissions, that is, nobody is missing, and no duplications, where nobody appears more than once. It's important to keep in mind that just like in SRS, perfection is the goal, but not the reality, and we often have to settle for an imperfect list. Once we have our list, step 2 involves creating a sampling fraction. You may recall that the symbol for sampling fraction is k, and k is determined by taking the size of your sample and dividing it by the size of your population. So for example, if we had 1,000 people in our sample and we had 16,000 people in our population, k would be 1 over 16. Step 3 is where we select our first case. For example, we determined in step 2 that k equaled 1 over 16. We therefore need to select a number at random between 1 and 16. But why 16? Remember in our hypothetical example, we wanted to select 1 out of every 16 cases. So 16 was determined by k. Once we've determined the number of cases that we have to select from, the next step is rather simple and might look familiar. That's right, we simply need to put 1 through 16 into a hat, a box, or a bin, and then pull out randomly one of the numbers. In step 4, we come back to the list. We need to select our first case. We do this by picking the case off the list that we chose in step 3. In this case, it'll be between 1 and 16. Step 5 is the most systematic of the steps. This is where we take every kth case after we select our first case. The kth case is unsurprisingly determined by k, which is simply, again, the size of our sample divided by the size of our population. Let's say, for argument's sake, in step 3 we chose 9 out of the hat. This would be our first case, or case number 9. We then would take every 16th case after that, so this case 25, 41, 57, and we would stop once we've selected out 1,000 people for our sample. As it turns out, this process is equally as random as simple random sampling. I've had many students question this and say it simply can't be true. I assure you it is, and that is because our first case was selected completely at random. So while each remaining case is taken at an equal interval, they are equally as random. As it turns out, systematic sampling is so useful, it's the most popular way we sample in social science research.